it?
F equals delta M. Or is it
Technically, although it gets you the right number value, technically it's I equals mv.
or the impulse?
Yeah, because
What's the impulse?
yeah,
MV,
yeah, because the units are slightly different. In the for the rocket, the delta m is mass per second, whereas in the impulse formula, it's mass. Yeah. Okay, so the first one, what is the impulse? Well,
0.12.
it's just 0.4 multiplied by 0.5.
No,
So-
but it's kilogram and it's meter per second.
Yeah.
So we must turn the 0.5 divided by 100.
No.
Yes.
No.
Why? Because they are different.
No,
Kilogram.
this is fine.
0.2.
0.4 kilograms and 0.5 meters per second. Look, impulse is m multiplied v, which is 0.4 multiplied 0.5, which is 0.2, and the units
kg.
kgm per s. Yeah. What should you not do about the units? You should not forget them. Okay, because what will happen in the exam if you forget the units? You lose marks unnecessarily,
The units,
totally unnecessarily.
the
Yeah,
units, we must not forget it.
you definitely must not forget them.
Thanks.
Yeah. Please do not forget them. Okay. Right, so that was very straightforward to get started. Second one now is getting a little bit difficult. Let's just read it together before you try it. A cat falls off a roof that is 5 meters high. The cat has a mass of 5.5 kilograms. When the cat lands, she bends her knees to soften the shock of landing. Do you remember we had an example like this with the man that jumps off and he bends his knees? The bending of the knees lasts 250 milliseconds. So a quarter of a second is how long the knees are being bent for. And my question is, what is the force that is felt by the cat during the landing? And my hint for you is you should first calculate the impulse experienced by the cat. Okay? So obviously the cat's momentum is going to change, because if you look, firstly the cat has momentum, and then when the cat lands it has no momentum, so obviously there is a change in the momentum. My hint is to first calculate that. Okay? See what you can do with this. Try this one. If you want to calculate the impulse, you need to know the mass and the velocity, yes? Do you know the mass? Yeah, do you know the velocity?
Yeah, 9.9.
No, but can you know it?
Distance over time, speed data.
No, goodness no. No. U-V-A-T-S. The cat jumps off. What's the U? Zero. What's the V? Don't know, that's what you want. What's the A? Minus 9.81. What's the T? Don't know. What's the S? Minus 5. Wakey. Everybody's asleep. Come on.
U is 0. T is 1.
Excuse me. That language was? Yeah. Keep it English.
Well, you should take that as minus 1.
Yes. Is that what you're asking in Arabic? Yeah, you see, but if you asked in English, then I would have been able to answer straight away.
So the minus 5, so the 5 will be the
Minus for S. 5 meters.
No, I'm talking about the 5 meter. Because BT
The 5 what?
5 meter high
Yeah, is the S.
is the S. Okay. So why we will
Minus
make
5.
it minus
Because the cat is going down.
okay.
Minus 98. So the acceleration will also be minus.
Mm-hmm.
98.1 V square.
Um,
9.92. V equals to 9.92. And versus and V. So multiplied and put 54. I found the input. Now I have to find the code.
You have the inputs,
Here.
and you can get the force. Do you remember your formula that you need from the last time? You see, because there's a formula.
Yeah.
Yeah.
Right.
Why do you sound surprised?
No.
Yeah, the force is delta P
Yeah,
over
one
delta T.
But we don't know the E.
Don't we? The bending of the knees lasts 250 milliseconds. Now it's all making sense.
Milliseconds multiplied by 10 minus 2.
Try again.
10 minus 4.
Try again.
6.
Oh no, wrong direction. Too
Well.
much. Too much. 10 minus 3.
Oh.
Milli is 1,000. Get an answer, Andy? What did you get? Did you get the V?
No, not like that.
Oh, come on, Andy, you can get the V.
I never got the detail. I use V squared equals U squared plus 2AS.
Fine.
V squared equals
U squared plus 2AS, fine.
minus 9
Yep.
over 8.2. But the calculator doesn't show the V.
What do you mean?
Oh, he has done he got the answer and then he put this, and then he didn't put the answer.
Huh?
The answer is 217.8.
Ah, anyways, I'll do it. Okay. Now,
And under root there is no minus.
Yeah, I was pressing
In
the
your whole life.
I was pressing the answer and I was typing it out.
okay. Okay. Hey,
Sorry.
you look for?
Just wanted to check that the draft had made.
Oh, you
There's
did?
a little bit of confusion this morning.
Oh, okay, okay.
So I'll see you back here at 2 o'clock? Yeah?
This room?
Yeah, we'll do the math back here.
And
What?
are there other pupils there?
Sorry, what's that?
Math test.
Did you get the email from me?
No.
Okay. Because if you didn't get, I sent you an email yesterday with the timetable for today, but if you didn't get it, then there must be an error in your email address. So can you just write down your email address, please?
Were there other people in the test too?
You can go back to
And then
Okay,
delta P
yeah,
upon T.
I have a
Delta P.
spreadsheet,
Like,
yeah.
I
I
don't
think
think
so. But I thought there was
delta P.
another girl that started this week.
Oh.
She needs to take me.
Yeah, I'm glad for that.
Yeah.
Where's the phone?
She's a science student, so she's in biology now as a cab. Yes. I don't know if it's a single or a double. I have a double now, but I don't know. I think the Irish is probably a double as well.
I think with the tutorial after.
Yes.
She was in cab anyway. She might be there.
Oh, it's the same. Okay, fine, fine.
So it's not being here yet, 2 o'clock.
Yeah.
Sometimes I can go wrong, like, point decimal.
Okay, let's have a look at this now. So, how high is the cat?
5
We said 5 meters, didn't we?
Yes.
Right, so here's my cat, and off it goes. Let's get the speed when the cat hits the ground. U 0. V, don't know. A, minus 9.81. T, don't know. F, minus 5. What formula did you use, Adnan? V squared?
2s v square minus
Yeah.
u square.
So, V squared equals U squared plus 2AS. And of course, what did I do? S is minus 5. 2 times 9.81 times 5. So V squared equals 98.1. So V equals the square root of this. And there's technically two answers,
Yeah, but we'll take the
but we'll take the minus answer. Yeah?
Why the money?
Because which way is the cat going when it hits the ground? Down. Right? Okay, so that's the first part. So, let's zoom in on the cat. So here is my cat. I shall make it ugly and big to make it clear. So this is when the cat first hits the ground, and then what's going to happen is the cat bends the legs to come to rest. At this point in time, when the cat just about touches the ground, it is still going at 9.9 meters per second into the ground. At this point, when the cat has come to rest, of course it's no longer moving, so it's 0. Because the cat bends its leg and then stops. So the cat goes from 9.9 to 0 in a very short time. What's the time? 250 milliseconds. So very quickly the cat comes to rest on contact with the ground. So we can easily calculate the change in momentum. Do you remember the impulse is the change in momentum, which is mv minus mu. But the mv is, what's mv? 0, because the v is 0. So it's just minus mu, which would be, how fat is the cat? 5.5, is it?
Yes.
So minus 5.5 times minus 9.9, because it's going down. So I get an impulse of 54.47, roughly, kilogram meters per second. Now, Iyad, did you get that far, or?
Yes, I just didn't write the
sign.
unit.
Outrageous!
Sorry.
Yeah, okay. Now, we can use Newton's second law. What's Newton's second law about the F? F equals impulse over time, which will be 54.47 over 0.250. Which is 217.9 newtons about.
Examples, 5 point.
No, 54.47 is what I got.
I got 54.45.
What the? Fine, come on, let's move on with our lives, okay? We're all going to round slightly differently by taking different number of decimal places, okay? I thought you said 5 point something, now that's a problem. 54.45? Fine. In fact, 54.45 still rounds off correctly to three significant figures of 54.5. Yeah. So, is this the answer?
Yes.
Well, we have to read very carefully, okay? It says, how much force is felt by the cat during the landing? So yeah, that would be how much force is felt by the cat in total, but it's not really how much force is in the legs. It depends what way you want to think about it. Like, if you were to look at the cat, here's my cat now, okay? That F is the total force, okay? It's the total force. But there are two forces acting on the cat. What are they? The weight, which is 5.5 G, and the reaction. And in the landing of the cat, which is bigger? When the cat is bending her legs, which is bigger?
The 5 G
The 5.5.
No, because if the 5.5 is bigger, it means the cat is continuing into the ground. But the or must be bigger because it must be like brakes slowing the cat down. So the or is bigger than the 5.5 G. Okay, because if it wasn't bigger, then the cat would continue to go into the ground. Okay, so the reaction will be bigger until when? Until it stops, and then it's equal. Okay, so the total force, or minus 5.5 G, is equal to 217.9. So if you want to know what the cat feels, you need to know what the reaction is, because the reaction is always what you feel when you're pressed against something. Okay, so it's not actually 217.9, it will be bigger than that. Or will be 217.9 plus 5.5 G. Now I should say, in the exam, usually this is the answer, because the question will just simply say, what is the force, as in what is the total force. But what is the key word that made my question a little sneaky? Felt. Because the cat feels in its legs the reaction. This is what is felt. And this is why you have to read carefully sometimes, okay? So what do we got here? .272 newtons is what is felt. Okay. Iyad, how far did you get when you tried this just now?
I got it all right, and I didn't get.
You got to here, did you?
Yeah.
Good job. You too, Mir?
To the post.
You got to this then?
Yeah.
Okay, but you didn't use this formula.
No.
Okay, but do you understand what I did here? Yes? Yes? Okay. 272 newtons. Yeah. Okay. Now, the next one is another wind example, but just before you started, there's a small difference. I would like you to read it and tell me the difference between this example and the example I gave you.
I think that this one's not felt.
No?
No, it's talking about the distance and the wind.
That's the same. Well, what's extra here?
My force is extra.
No,
The one I'm
no.
giving.
That the
One you
give
say.
the
No,
density of the wind.
No. In the example I did for you, the student is stationary, at rest. In this version, the student is walking into the wind, and that actually increases the force, which makes sense. If you are walking into wind, you feel it harder than when you're not walking into the wind, right? So that actually makes a difference. So the question now is, before you start, I want someone to tell me, how do you deal with that 1 meter per second in the story?
I felt it with the wind speed.
Correct. Why?
Because I'm going to like opposite of the wind.
It will be mine.
Yeah, he got the idea, it's just difficult to explain, yeah. But you have the right idea. So look, if you're standing still and the wind's blowing at you at 20, then in 1 second, 20 meters of the wind comes towards you. But if you're walking to the wind, it's almost like you're helping the wind come to you faster. You know, so like the 1 meter step you take forward, that's 1 meter the wind doesn't have to move because you moved into it. So the wind will still move the 20 meters, but it's like you've helped it by 1 meter. So in total, 21 meters of wind is going to hit you. But then that makes you realize, oh, so if I take 1 step back, how much wind would hit you? 19 meters, because what's happening is, by taking 1 step back, you're making it harder for the wind. Yeah. So this is all called, well, I don't know if anyone knows the word, it begins with an or. When you look at the motion, when you compare the motion of two things.
Opposite?
Not this. Does anyone know? Do you know the word relative?
Yeah.
Relative? Relative means you don't care about this, you don't care about this, you care about the related movement. Okay? So yes, the man walks at 1. Yes, the wind blows at 20. Yeah?
Can I go to?
Yeah, go ahead, Jeff. Yes, the man walks at 1. Yes, the wind blows at 20. You don't care. You care that the difference between them is 21 or 19, depending on if they're coming closer or they're separating. Yeah? Okay, so now that you know that, I think you can do the question. Also, I want you to use your numbers. If you were to imagine yourself as a rectangle, how tall and how wide would you be? Yes?
2.5 tall.
2.5, no way, man.
I am 6, like,
Yeah?
6 tall, and then
You're 6 meters tall?
He wants to be.
How tall, do you know how tall you are?
I know that I'm 6, but I don't know the unit.
6 feet.
Yeah, 6 feet. I don't know the unit.
I think that's about 179 centimeters, I think. Do you know your height?
Yeah, I'm on that.
Okay, and so, is he about 10 centimeters taller than you?
Yeah.
180, 170. How do you compare to these two?
I'm him bigger than him. I'm taller than him.
Alright, then 175 then. 175.
I'll say 180.
Split the difference. Okay, that's fine. Do you know your height, Andy?
Yeah.
Okay. Okay, you'll have to estimate how wide you are as well.
24.
How, you're 24 centimeters wide?
No, 24 meters.
You're 24 meters wide?
No, when we, made
No, that's your pant size. 24.
That's so different.
That's so different. Literally, if you were to put your hands apart in front of you, how wide do you think that is? Because that's what you care about, because that's
Okay.
facing the wind.
Okay, it's like,
Just say 30 centimeters.
so it must be
30 centimeters, you said 30. Okay, try this now.
like you can measure with the hand too, like it's like here.
Yeah, and this is the thing. If you increase your area, you'll get more force as you walk into the wind. Because in the calculation, you care about the volume. So by doing this, what are you doing? You're making the volume bigger because there's more wind. Yeah. So you're right. But we'll just say we're walking,
Yeah.
okay? Okay, try this.
So it plus the see where
Yeah, 21, so.
he's going towards the
Towards the wind.
yeah, towards the wind. So it's cutting, like if it was 20, now he's cutting the wind 1 meter.
No, he's adding to it. When you walk
It's
into
going
the...
close to it, like
Yeah, you're walking into the wind. You, in other words, are helping the wind to hit you by walking into it. Let's just put it, imagine it like this. If you have a car coming towards you, which will hurt more? If you run into the car to meet it, or if you try to run away from the car?
I will try to run away from the
Exactly, because if you run into the car to meet it, it will increase the impact. Yes. Yeah.
Density equals M over V.
Yeah, and the density here, we're being a little bit more accurate, it's 1.225. Whereas in my example, I just said 1.
I'm 180. What about the 30?
30 we'll say.
Okay, so the distance of the wind is like 21 meters. And you can
Yeah. Oops. You have an answer over there?
Yeah.
What did you get?
275.
And Mir?
Yes.
Okay. Adnan?
1 second, please.
And the same for 180. It's like 10 and 3.
Oops. Adnan?
I'm guessing it's too small.
Oops.
Yeah, it's
Alright, let's have a look. So, we'll go with, Andy. How tall are you, Andy? Do you know?
I hope 175.
Okay. How wide do you think you are?
70 centimeters.
Oh, I don't think you're that wide. 70 centimeters.
20
You are
centimeters.
not there.
I don't think you're 20 centimeters either. We'll just say 30 centimeters, will we? Yeah. And how long is this? 21 meters? Okay. So, you know,
Try to find a-
yep, that the force,
About 0.0.
Mir, what's wrong? Did you get an answer? What you get?
0.06615.
Oh no, it is way too small. Let's have a look. Force Look up. You can look up at what I did, because the number should be similar to yours. Delta M, delta V. We know that density equals mass over volume, so volume equals density by mass. So this would be M density, So mass equals density by volume. So this would be density, volume, and the speed. Now the density, what we said was 1.225. The volume will be 21.3, 1.75, and the velocity is 21. Yeah? Because if you are walking into the wind at 1 and the wind is blowing at 20, it's like the wind is going at 21 into you. Perspective.
The way we did the second one. So we find the V.
Not the second one, the first. This.
How?
What answer did you get?
At me?
Yeah.
275.
Yeah, okay. So we should be looking at answers like this number.
Yeah, 291.
Okay. If you bend down as you walk, so you're only half as tall, what happens to this number? Half. Because the 1.75 gets divided by 2. So when it's very windy, this is why sometimes you see people bending down as they walk, because it reduces the force. Yes?
Yeah.
Make sense?
Okay.
Yeah? Yeah?
I've got 292. When it's 1.8.
What did you get?
292.
292. Because you are extra tall and extra wide, is it?
Yeah.
Yeah. What did you say here?
It's the same, but for
You
the
made yourself taller
1.8,
then.
Yeah.
Yeah. Okay, good. Okay. I've seen this question in the exam, but they made it like a question with they had outside a shop. There's a shop sign, like coffee or whatever. Come inside, and they said the wind was blowing on it, and they wanted to know how much force is being felt by the coffee sign from the wind. Then, so it's the same idea. Okay. It's a little bit easier with a coffee sign because it is a rectangular shape. Right, now the last one here, which we'll do together, and I think we'll do it part by part, okay? So, we have, let me just draw what we have here. We have a rocket. The rocket is 100 kilograms. However, look, 90% of it is fuel. So how much of this is gas?
90%.
Yeah, so 90 kilograms is gas, and therefore how much is not gas? 10 kilograms. Okay, so the gas comes out at 9 kilograms per second at a speed of 100. And my question firstly is, what's the weight? So first question, try this please, what's the weight? So this is what we have here.
I don't know.
Okay, but you can still write the question down.
You need to write the question. Like,
No. If you understand it, you can just write the draw the picture, okay? Okay, so the first one, what's the weight?
mg.
Yeah, so what would it be here?
M is
Andy, what's the weight?
90 multiplied by
Wait, Andy.
92.
Yeah, what's the weight? Weight is in newtons. Remember the formula for weight? So what's the weight here? Part A. Weight. Andy, what's the formula for weight? Come on. Weight equals... Andy, please. Andy? Oh, Andy, you're breaking my heart here. Andy, it's mg. Yeah, come on. So what's the m here?
90.
90 kilowatt.
No, 100. The rocket is 100 kilogram rocket. I mean, look, if you have a weighing scales underneath, does the weighing scales care that 90 of it is fuel and 10 of it is not fuel? No, of course not. So the weight is 100 G, okay, which would be 98.1 newtons. Okay.
No,
B.
981.
What?
Yeah.
It's 98. No, it's not 90.
Apologies, 981 newtons. Okay, part B. What is the reaction force?
Plus 10.
What's the R?
Plus
Anybody reaction force?
I know it's 981 gram on that side.
What's the R?
981.
981 newtons. Yeah, because it's at rest. Because it hasn't taken off yet. Yeah, so it's just 981. Now, I want to know what is the thrust. What's the meaning of this word, thrust? The upward force. So where is this force coming from? It's coming from the rocket when it's turned on. And you all remember the formula. I'll just write T for thrust. It's equal to delta M delta V. Now what's the delta M here?
9 kg.
9 kilograms per second. And the speed of the gas?
100.
100. So then it is 900 newtons. Yeah. Okay. Is that okay so far? Okay, I don't know if you look confused or hungry.
No.
You're a bit hungry, okay, alright. Are you confused?
No.
No, okay, well that's good. Okay, part D is what is the reaction force when at T is 0, when the rocket is turned on. So, yeah, when it's at rest and the engine is turned on, so now we have three forces. The reaction from the ground, the weight, and now this thrust here, yeah. So in part D, what are the forces going up? It'll be T plus R. And the force going down?
981 G.
Yeah, 981, the weight. So you have 900 plus R equals 981. So the R equals 81 newtons. Now I didn't actually say this, but if you just look here at the last part, what's the weight of the rocket? No, weight. 981 newtons. How much force does the rocket engine provide? 900 newtons. So will the rocket move? No, because if this is 981 and this is only 900, it still won't take off. This is why we still have a reaction force, because the rocket is still resting on the ground. However, why is the reaction less now? Well, because the engine is on pushing up. It's a bit like the example with the block, and when the man has the rope, and he has the rope and he pulls it up but it doesn't move. What happens to the reaction force? It decreases. Yeah, it's exactly the same idea. So the reaction is now 81 newtons. Okay. Right, so the rocket doesn't move. This seems like a problem, doesn't it? No, it's not a problem.
Well, I mean, yeah.
It's a problem if you want the rocket to
Yeah.
move, yes? Okay. So part E is why doesn't it take off?
So the reaction force is bigger.
Well, not because of, let's talk about thrust and weight. So the reason is for part E, the thrust is smaller than the weight, and that's why it doesn't take off. If you wanted to take off, the thrust has to be at least equal to the weight. Yeah. Okay. F now. When will it take off?
When time will increase.
Yeah.
When time will be greater than 0.
No. Well, yeah, but when? At what time will it take off? So it doesn't take off at the beginning.
Because when it takes off, the reaction is less than...
No. What is the reason it is not taken off? Than the weight. Or, say that a different way. Say it backwards. Say it with the word weight at the start. So it doesn't take off because the thrust is smaller than the weight, or it doesn't take off because...
The weight is bigger than the
Thrust. Will the weight always be bigger than the thrust?
Right?
Will the weight always be bigger than the thrust?
No.
No, not.
Why not?
Sometimes it.
No.
Okay, but how?
What is happening every second?
more gas, the mass is getting less.
That's it. As the gas comes out, the mass is being reduced.
Yeah.
At some point the weight will be small enough for the rocket to take off. And this is why when you see rocket launches, they don't seem to move at the beginning. They take time. So we need to know when will the thrust be strong enough. So we want, if the thrust is, 900 newtons, we want the weight to equal 900 newtons, correct? So we want the mg to equal 900, so we want the m to equal 900 divided by g, which is 91.7 kilograms. At the beginning, what's the mass of the rocket? It's 100 kilograms. After 1 second, what's the mass? 90 kilograms. No, sorry. How much does it lose per second? 9. So after 1 second, it's 91, and then after another second, it's 82. So basically, after about 1 second, it's light enough to take off. Nearly 1 second, maybe 1.1 seconds. So the answer I'll say here is after 1 second, it can take off. So when the time is bigger than 1 second. Okay. Are we getting the idea for this now? It's difficult, but each part is understandable. Okay. Right. I want to do the next lesson, which is actually quite short, so it's okay to get it in for 15 minutes. But I want to leave the last part. The part G we can answer it quickly enough. How long will the fuel last? So how much fuel do we have in total? How many? 90 kilograms. And how much is used per second?
9.
So 10 seconds. If it's 90 kilograms and you use 9 a second, then you'll have 10 seconds of fuel. 90 divided by 9, 10 seconds. Okay. E, F, G, H now. This is for homework. The H. The difficult one. Yes, now. I really, really want you to try this. Try it hard.
Okay.
Think about it a lot, okay? I'll give you some hints for it. So what's going to happen is the rocket will be on the ground. 1 second later it will take off. It will increase, but of course what happens after 10 seconds?
It's from
The
nothing.
fuel runs out, and then it will come back down. Now, if you think about the order here, okay? When it takes off, what are the forces on it? There's two forces when it's moving in the air. What is it? The thrust and the weight. Okay? So, you can use Newton's second law to calculate the total force, the thrust minus the weight. What will this give you? If you have F equals ma, what will this give you? You can get the A. Yeah?
Yeah.
So we'll say U is 0, yes? Okay? And the A we can calculate it. And the time? We already have it. It's 10 seconds. So for 10 seconds it is accelerating up into the air. Then what happens after 10 seconds?
The fuel runs out.
Yeah, so what happens then to this?
Comes down.
No, it doesn't go down. What happens?
Stops.
No, it doesn't stop.
It goes.
It continues to go and slows down and then falls down. Okay, so do you understand? From here to here, this is F equals ma problem. But then what type of problem is it after that?
It's decrease.
Yeah, what type of problem is it after that? It's a projectiles problem,
Yes.
where it's just thrown up in the air.
Yes, maximum.
So it's like when the engine is cut off, it's like the same effect as throwing it up in the air. There's no more force, it just goes up and comes back down. So this problem you have to do it in two parts. The first part is the accelerating up until the rocket cuts off. Then the second part is a projectile to the maximum height. But when you go from here to here, you have F equals ma. Do you know the F? Yeah, it's the thrust minus the weight. Do you know the M? No, because the M is changing.
Oh.
It starts originally at 91 kilograms when it takes off, and then when it runs out of fuel, what is the mass? 10 kilograms. So what can you do if the mass is changing? What can you use instead?
The average.
Average.
The average mass, which is about 50. Okay. So do you understand this question? It's a good one for a homework because you are putting so many ideas together from what we've done so far. Do you see what I'm saying? You have average mass, F equals ma, projectiles. It's all being put together. So I wanted you to try your best for this last one. We'll have a look at it next time. Okay. Yeah, so just write in your book what is the maximum height, and you can try it at home. We'll continue now with the next topic.